Hi Year 9. Today what we're going to be looking at is reviewing probability. So your learning intentions today is to understand the concept of probability and how it's described numerically, to know the terminology of probability, to be able to find the probability of an event in an experiment with equally likely outcomes, to be able to find the probability of a complement of an event. You'll feel successful today when you can find probabilities of events. So a chance random experiment is an activity that may produce a variety of different results or outcomes which occur randomly. So rolling a die is a random experiment. The sample space is the list of all possible outcomes from an experiment. So for example, when you roll a die, your sample space are the numbers 1, 2, 3, 4, 5, 6. We use set brackets, which are our curly brackets, to list the sets of numbers or other objects. N is a collection of outcomes resulting from an experiment. So when we're rolling a die, it is a random experiment with six possible outcomes, 1, 2, 3, 4, 5, 6. The event rolling a number greater than 4 includes the outcomes 5 and 6. This is an example of a compound event because it contains more than one element from the sample space. The probability of an event in which all outcomes are equally likely is given by the probability of event equals the number of outcomes in which the event occurs divided by the total number of outcomes. Probabilities are numbers between 0 and 1 inclusive and written as a decimal fraction or percentage. The complement of an event A is the event in which A does not occur. We calculate the probability of not A by going 1 minus the probability of A. Let's have a look at some examples. Our first example here, we have this spinner and it has 5 equally divided sections. What we're going to do is we are going to list the sample space using the given numbers. So what we're going to do is we're going to use our curly parentheses and then we're going to list all possible outcomes in any order. I'm going to list them in numerical order. So I'm going to go 1, 2, 3, and 7. We don't need to double up on outcomes. We can just write the different types of possible outcomes. For part B, we've been asked to find the probability that a 3 occurs. So what we do to find the probability that a 3 occurs is we work out the number of sections labelled 3, which in this case is 2 out of a possible 5 sections. Now, when doing probability, you can write your answer as a fraction, decimal, or percentage. I personally like writing my answers as fractions, so I'm going to keep my answer as 2 over 5. What we have next is we want to have to find the probability of not a 3. So to work out the probability of not a 3, it is a complementary event of obtaining 3. So what we're doing is we're going to go 1 minus the probability of a 3, which is what we just calculated. So we're going to go 1 minus 2/5, which is equal to 3/5. Next, we want to find the probability of a 3 or a 7. So what we want to do is we want to look at how many 3s and 7s we have. And looking at our spinner, we can see that we have 2 3s and 1 7. So that means we have 3 of either 3 or 7 out of a possible of 5. Finally, the last question is to find the probability of at least a 3. So we want to look at the number 3 and any numbers that are larger than 3 or greater than or equal to 3 is what this is also asking. So what we have is we have a 3, a 7, and a 3. So again, our answer is 3 over 5. Moving on to example 2, what we have is a letter is randomly chosen from the word aeroplane. We want to find the following probabilities. So the first thing we want to do is to total or work out how many total letters there are. So total letters is 9. Yep, 9. And then we want to look at our question. So we want to find the probability of an R. So how many R's do we have in the word aeroplane? The correct answer is 1 out of a total of 9 letters. To work out the probability of not an R is going to be 1 minus the probability of an R, which is equal to 1 minus a 9th, which equals 8 over 9. Now, the probability of a vowel, what we have is vowels are our letters in the alphabet that contain A, E, I, or U. So if we have a vowel, the letters that are vowels, we have A, E, O, A, and E. And so there was 5 of those letters. So the probability of a vowel is 5 over 9. Our consonants are then the other letters in the alphabet, and they, in this case, are our R, P, L, and N. So there is 4 out of 9. Now, an important part in probability is making sure that we simplify our fractions. For both of these examples, our fractions have been in their simplest form, but if not, you always want to make sure that your answers are in simplest form. Okay, for E, we have to find the probability of a consonant or an A. So we know we have 4 consonants, and now we just need to work out how many A's we have as well. So if we have 4 consonants, so 4 over 9, plus how many A's do we have? We have 2 over 9 A's. So that's a total of 6 over 9. And like I said, 6 over 9, we need to check whether that simplifies, and it does simplify to 2 over 3. Finally, we want to find the probability of a vowel or a consonant. Now, vowels or consonants make up the alphabet, so this includes all possible outcomes, so it is equal to 1. Okay, what you're going to do today is you are going to do the independent task of exercise 9A, either using your laptops or the textbooks in the back cupboard. You're going to do question 1, you're going to do 2D, all parts, you're going to do 3 ACE, and then you're going to do questions 4 to 13, and you'll come back and do question 14 if you complete that, or to do some enrichment. Have a good lesson.